Welcome back to Mr. Vaughn's classroom. Before we get started, I'd like to ask you to please hit that subscribe button, give this video a thumbs up, and let's get started. Today we're looking at Unit 5, Introduction to Exponential Functions, Lesson 7, Using Negative Exponents. Our learning goal today is to look more closely at exponential graphs and equations. We have two learning targets. As we work through the practice problems, please keep these two learning targets in the back of your mind, and we will come back to them at the end and make sure you feel comfortable making both of these statements. Learning target number 1, I can describe the meaning of a negative exponent in equations that represent exponential decay. The key here is that a negative exponent means we want the reciprocal. We want 1 over the base number. Learning target number 2, I can write and graph an equation that represents exponential decay to solve problems. So we need to be able to write that exponential equation, which was y equals the initial amount times the growth factor to the power of the input. And we then need to be able to take those results we get from the equation and graph them. We have one glossary term for this lesson, and that is growth factor. In an exponential function, the output is multiplied by the same factor every time the input increases by 1. The multiplier is called the growth factor. Now we can begin the practice problems for Unit 5, Lesson 7. A forest fire has been burning for several days. The burned area in acres is given by the equation y equals 4,800 times 2 to the power of d, where d is the number of days since the area of the fire was first measured. So what this is saying is that originally the area was 4,800. And every day that goes by, that fire is doubling in size. That's why we're multiplying by 2 each day. Now they want us to complete this table. But notice that on the left, we have the normal 0 days since measurement. That's going to be that initial amount of 4,800. But then you start seeing these negative days. And what that means is that instead of going forward and doubling the size of the fire, we are going to be going backwards to previous days. That's what that negative is meaning. So instead of us saying 1 day after the measurement, 2 days after the measurement, and so on, we're saying 1 day before the measurement, 2 days before the measurement, 3 days before the measurement, and 5 days before the measurement. Also, we need to understand that when you use a negative exponent, that negative turns the base number into its reciprocal. So here, instead of multiplying by 2, we're going to multiply by its reciprocal, which is 1/2. So now what we're going to be doing is we're going to be cutting the area that's been burned in half because now we're going backwards in time. So, as I said, 0 days since the measurement, that's going to be the initial 4,800 acres that have burned on the day that they've taken the measurement. Now, if we use this -1 as the exponent, that negative is going to turn the 2 into 1/2. So now what we're doing is we're cutting that 4,800 in half, and that means it's going to be 2,400 acres that have burned. Now, if we use a -2 exponent, we're going to go back another day. We're going to cut this acreage in half again. So now that's 1,200. We go back to 3 days before. We're going to cut this in half again. And that was 600 acres. And then we're going to go back to 5 days before. So I need to cut this 600 in half to 300, and then I need to cut it in half again to 150. So you can see that we're continuing to keep this growth factor going. It's doubling every day. So it doubled from 150 to 300 to 600 to 1,200 to 2,400 to the 4,800 on the day it was measured. We're just working in the opposite direction now. So that takes care of number 1, completing the table. Number 2, look at the value of y equals 4,800 times 2 to the power of d when d equals -1. So we're looking at this row right here. What does it tell you about the area burned in the fire? So for number 2, it tells us the area burned by the fire 1 day before the measurement was taken. Was 2,400 acres. Then it asks us, what about when d equals -3? So now we're looking at this row down here. The area burned 3 days before the measurement was taken. Was 600 acres. Number 3. How much area had the fire burned a week before it measured 4,800 acres? Explain your reasoning. To find this, we can take the equation y equals 4,800 times 2 to the -7. We can put this into a calculator. We have 2 to the -7 power times 4,800, and we get 37.5. So that's 37.5 acres had burned 1 week before the measurement. And just to show, we knew that at -5, it was 150. Well, if we cut that in half again, we're down to 75 at -6, and then we cut that in half again, and we're at 37.5, 7 days before the measurement. If you have any questions about how to solve this practice problem, please leave a comment below, and I'll get back to you with any answers I can offer. Our next practice problem, the value of a home in 2015 was $400,000. Its value has been doubling each decade. Number 1, if V is the value of the home in dollars, write an equation for V in terms of D, the number of decades since 2015. So, number 1, they want us to write the exponential equation. So remember, we need 2 main ingredients for that. First, we're going to need the initial amount. And right here, they tell us the initial amount is $400,000. So we have y equals 400,000. We need to multiply that by the growth factor. Well, the growth factor, they tell us it's doubling each decade, so that growth factor is going to be 2. And then they know it's each decade, and they want us to represent that with D. And then I'm going to change, instead of Y, they said they want us to use V for the value of the home. So we have V equals 400,000 times 2 to the power of D. Number 2. What is V when D equals -1? What does this value mean? So we would have V equals 400,000 times 2 to the power of -1. Well, that negative actually means we have 400,000 times 1/2 to the power of 1. And if I multiply 400,000 times 1/2, then I have 200,000. They want to know what this value means. It means the value of the home was $200,000 1 decade before 2015. So this means back in 2005. Number 3. What is V when D equals negative 3? What does this value mean? Well, the value is 400,000 times 2 to the power of negative 3. Well, that negative tells me to make the growth factor its reciprocal. So instead of multiplying by 2, we're multiplying by 1 over 2, or 1/2. And we're doing that 3 times. Well, I know, without even using a calculator, that 1/2 times 1/2 is 1/4, times 1/2 is 1/8. So we have 400,000 times 1/8, and that is going to equal 50,000. And they ask us what this value means. It means the value of the home was $50,000 3 decades before 2015, also known as 1985. So again, the negative exponent means 2 things. Number 1, it means we're looking at a time in the past. So here we're talking about decades. So -1 means 1 decade before 2015. -3 means 3 decades before 2015. The second thing that a negative exponent tells you is that now your growth factor is going to become its reciprocal, or it's going to be 1 over the original growth factor. So now, if we were doubling going into the future, we are having it going backwards into the past. If you have any questions about how to solve this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Our next practice problem says a fish population P can be represented by the equation P equals 800 times 1/2 to the power of T, where T is time in years since the beginning of 2015. The question they're asking us is, what was the fish population at the beginning of 2012? So, first off, I need to notice that from 2015 to 2012 is going to be 3 years. And since we are talking about 3 years in the past, then we're going to use -3 for the exponent. So we have P equals 800 times 1/2 to the power of -3. The negative tells us we want the reciprocal of 1/2. So that's 1 over 1/2, which is 2. So we're going to have 800 times 2 to the power of 3. 2 to the power of 3 is 2 times 2, which is 4, times 2, which is 8. So we have 800 times 8. 8 times 8 is 64, and then I have the 2 zeros. So the correct answer is D, 6,400. To explain this so you can understand the big picture of what is happening here, the original equation said we were multiplying by 1/2 each year. So the population was getting cut in half every year. It was losing half the population. Well, if I go 3 years in the past, then I'm doing the opposite. I'm not cutting the population in half moving forward. I'm doubling the population each year moving backwards. So that's why the negative exponent tells us to multiply by the reciprocal. So the reciprocal of 1/2 is 2. Now we're doubling that population 3 times. So the 800 goes to 1600 in 2014. That 1600 goes to 3200 in 2013. And then we see it double again to 6,400 in 2012. If you still have any questions about how to solve this problem, please leave a comment below, and I'll get back to you with any clarification I can offer. Our last practice problem says the area, A, of a forest in acres is modeled by the equation A equals 5,000 times 5 over 4 to the power of D, where D is the number of decades since the beginning of the year 1950. Number 1 asks us, is the area of the forest increasing or decreasing with time? Explain how you know. To determine this, what you need to look at is the growth factor. And that is this number right here. This growth factor is 5 over 4, which is equal to 1.2. Because the growth factor is greater than 1, the area is increasing. Anytime your growth factor is more than 1, you are increasing. Anytime your growth factor is less than 1, you are decreasing. Number 2. What was the area of the forest in 1950? Well, the equation itself is made for 1950. So all we have to do is look at the number that's by itself, and it is the initial amount. So that means the answer is 5,000 acres. Number 3. What was the area of the forest in 1940? Well, A equals 5,000 times 5 over 4 to the power of -1, because we're measuring in decades, and 1940 is 1 decade before 1950. So anytime I have a negative exponent, it tells me to change the growth factor to its reciprocal. So 5 over 4 becomes 4 over 5. Now I can put that into a calculator. 5,000 times 4 over 5, which is equal to 0.8. And that gives us 4,000 acres. And we had said in number 1 that as we were going forward in time, the area was actually increasing. So this answer makes sense, that the area was only 4,000 back in 1940, and it had increased to 5,000 acres in 1950. And number 4, was the area of the forest less than 1,000 acres in 1900? Explain how you know. Well, we have the area equals 5,000 times 5 over 4 to the power of -5, because 1900 is 5 decades before 1950. The negative tells us to change the growth factor to its inverse, or its reciprocal. So we have 5,000 times 4 over 5 to the power of 5. Now we can put this in a calculator. 4 over 5 is equal to 0.8. We want that to the power of 5. And now we want to multiply by the original 5,000 acres in 1950. And that gives us 1,638.4 acres. So the answer would be no, it was not less than 1,000 acres in 1900. If you have any questions about any of the practice problems we've gone through, please leave a comment below and I'll get back to you with any help I can offer. Now let's take a moment before we finish and look back at our learning targets for this lesson. Now we can look at the learning targets and ensure that you feel comfortable making both of these statements. Learning target number 1 says I can describe the meaning of a negative exponent in equations that represent exponential decay. So there's 2 meanings that you need to understand. The first meaning is that we are looking backwards into the past. So we're making calculations for previous quantities as instead of moving towards the future. The second meaning is that negative in the exponent tells us we need to change our growth factor to its reciprocal. If it's a whole number, we need to put 1 over the growth factor. And if your growth factor is already a fraction, we need to flip that fraction upside down. Learning target number 2, I can write and graph an equation that represents exponential decay to solve problems. So first, you need to be able to write these exponential decay equations. And those are made up of the initial amount multiplied by the growth factor, and the growth factor is to the power of the input. Once you've written your equation, you need to be able to substitute values in for the input, calculate your output, and then plot those input-output point pairs. If you feel comfortable making both of these two statements, then you are right where you should be. If you still have questions about either of these learning targets, please leave a comment below, and I will try and get back to you with any help that I can offer. I hope you found this video helpful. If you did, please hit the subscribe button and give this video a thumbs up, and I look forward to seeing you in the next lesson.